All right, Chapter 9. So, Google Cloud Platform Tools. As your Google Cloud architecture matures, so does your need for automation. You want to move beyond manually spinning up instances or configuring networks from the console. Instead, you want to treat your infrastructure like code, modular, versioned, repeatable. That's where Google Cloud Deployment Manager comes in. This is where we are on the screen. What is Deployment Manager? Deployment Manager is Google Cloud's native infrastructure as code tool. Think of it as your personal infrastructure orchestrator, allowing you to define, deploy, and manage GCP resources using declarative YAML configuration files and optional templates written in Jinja 2 or Python. Whether you're provisioning a single VM or deploying a full stack web app across multiple services, Deployment Manager ensures your infrastructure is deployed the same way every time. So the core building blocks of deployment manager. Let's break this down in those four foundational concepts. Configuration. This is the heart of your deployment. A configuration file describes all the resources that make up a single deployment, such as virtual machines, load balancers, app engine services, BigQuery datasets, and Cloud SQL instances. Each resource entry in your YAML must include a name, which is a unique identifier, type, the GCP resource, like a compute.v1.instance, and properties, configuration parameters like zone, disk size, or machine type. And two, a template. All right. Templates let you reuse logic across multiple deployments. Instead of copying and pasting YAML code for every project, you modularize common infrastructure patterns. Templates are written in Python and Jinja 2 and can be imported into different configuration files. For example, if every application in your organization spins up 4 VMs and 3 BigQuery datasets, you can bundle that logic into a single template and then use it across dev, test, and production environments, just like calling a function in code. Three, types. Each resource has an associated type, which defines how that resource is handled. A base type refers to a specific GCP API resource, like compute.v1.instance, right? A composite type is a collection of base resources bundled together, a reusable like a template, right? This type ensures your deployment knows exactly which API to call and how to provision the resource. And then four, the manifest. Every time you launch or update a Deployment Manager automatically generates a manifest. This is a read-only snapshot of the exact configuration and resources used. It includes metadata like the resource names and types, config file versions, and input-output parameters. Think of it as an audit trail, a record of what was deployed and how. So let's deploy it with a hands-on example. And let's walk through deploying a single VM using Deployment Manager. So step one, let's install Cloud SDK and set the project. Uh, okay. Authorize the shell. Project ID. Okay. So let's do this. Gcloud config set project with the project ID. I just copied and pasted. So we're here. Okay, we're going to create a configuration file. Now I have one already copied. So what we're going to do, okay. Yep, did I go in here right? Deployment manager. Oh, wow, so this is going to stop. All right, let's try and do this. Let's see. Oh, wow, so it is shutting down. So probably not be able to do this. But that's okay. We'll keep going. Well, the YAML file would define a virtual machine using a Debian 9 image connected to a specific VPC network with NAT access enabled. Unfortunately, I can't show you that. So you can deploy the configuration with code to deploy the YAML. And I'll show you the correct one. Here is what it will look like. So that's gcloud deployment manager deployments, create deployment 1 VM, that's the name, .config or -config 1 VM .yaml. And that'll be the name of that YAML file. If the deployment manager isn't enabled, you'll be prompted that it needs to be enabled. So just type yes or Y and continue. And then you confirm success that your YAML is created and validated, and it spins up the VPN or VM and confirms the deployment with a status message. And that'll show you created your infrastructure as code. And then you can clean up the deployment with the following: gcloud deployment manager deployments, delete deployment 1 VM, and this tears down every resource created. There's no clicking through the console required. So why this matters: deployment manager makes infrastructure deployment consistent with no manual errors or configuration drift, automated so it deploys at the speed of the CI/CD, and auditable so you know exactly what was deployed, where, and how. It's ideal for standing up dev test environments, enforcing baseline configurations, and deploying complex systems with repeatable patterns. And most importantly, it integrates seamlessly with version control, CI pipelines, and cloud build for end-to-end automation. And that wraps up your journey into Deployment Manager, a crucial tool in the Google Cloud toolbox for scalable, manageable infrastructure. So imagine you've been tasked with standing up a WordPress site, a MongoDB cluster, or perhaps a full data analytics pipeline on short notice. You're not looking to reinvent the wheel. You just need trusted software deployed quickly, securely, and reliably in Google Cloud. And welcome to the Google Marketplace. This will be your one-stop shop for prepackaged applications ready to go with just a few clicks. Let's see. Let's go to the Marketplace. All right, so I believe this is the security marketplace. So let's try this one more time. Let's go back. Google Cloud Marketplace. Okay. So this is the marketplace, right? Google Cloud Marketplace is like the App Store, but for enterprise software and infrastructure. So it provides production-ready solutions maintained by Google or third-party vendors, and it's optimized for deployment on Google Cloud Platform services, including Compute Engine, Kubernetes Engine, App Engine, and Cloud Run. From here, you'll find everything from content management systems like WordPress and Drupal, developer tools like GitLab and Jenkins, databases like MySQL, MongoDB, and Redis, and security tools, monitoring platforms, machine learning frameworks, and more. Each listing is carefully curated to work seamlessly within your GCP environment and includes pre-configured network, IAM, and firewall settings. So here's a simplified walkthrough launching WordPress from the marketplace. Let's try it. Look for WordPress. All right. So we'll see this one. We look for WordPress. We'll find several options with high availability. We'll select this one. Okay. Get started. All right. Oop, that's going to cost. So we're only doing a training here, so we're not going to actually click that. But here's the simple thing. You click get started. After you see it, purchasing, agree, and you go forward with that. So with the deployment, you can orchestrate the creation of compute engine instances, the disks, the firewall rules, the network interface settings, and the WordPress software pre-installed. So from here, you can monitor deployment. So once you click deploy, you'll be taken to a progress screen. Let's see if we can go back here. So from here, you'll be able to monitor this here, right? And here you can see resource creation logs, network status, any errors or warnings in deployment, and once complete, a public IP address where WordPress is accessible. The whole process takes place in under 5 minutes. So when you clean up, you can do this when you no longer need the solution. You can go to the Deployment Manager, select the deployment, and click Delete, which would be down here. From here, it'll automatically remove all associated components like the compute VMs, the compute engine VMs, the firewall rules, the network interfaces, the persistent disks. This is especially important for cost management, as idle infrastructure still incurs charges. Security, licensing, and governance. GCP Marketplace solutions often come with verified security hardening from Google or certified partners, built-in IAM bindings for principle of least privilege access, and clear licensing terms, including bring your own license or usage-based pricing. You can find this directly in the product listing, including license costs, support contact info, and release notes. So why use the Google Marketplace? Here's what makes it a critical tool for developers, architects, and platform engineers. The speed to deploy. You no longer need to configure just from scratch. Security-aware defaults and hardened images. Repeatable infrastructure via deployment manager. Visibility into costs. Each deployment integrates with cloud billing. And enterprise-ready, high availability, scale-out options, and partner support. You can even automate marketplace deployments via Terraform, Cloud Build, or the REST API. And this brings them into your CI/CD pipeline and infrastructure as code workflows. So that wraps our look at the GCP Marketplace, a powerful shortcut to launching everything from proof of concept jobs to production-ready stacks in a matter of minutes. Okay. When most people think of managing cloud infrastructure, they think about imagine dashboards and drop-down menus. But for power users, engineers, and automation wizards, there's another tool of choice, the command line, which we've been showing you today. So let's go to the Cloud SDK. This is the command line interface for Google Cloud Platform. We'll walk through what it is, how it works, and why it's an essential part of your toolkit. What is the SDK? The SDK is short for Software Development Kit. It's a suite of tools that let you create, configure, and manage Google Cloud resources from your terminal. No browser required. At its heart are three primary tools. G-Cloud, core command line tool for managing almost everything and anything in Google Cloud. BQ, the command line tool for interfacing with BigQuery. GSUtil for managing cloud storage. Show you G-Cloud, 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 BQ, GSUtil. Okay? These are bundled together with additional components under the umbrella of the SDK core. Whether you're on Linux, Mac OS, Windows, Debian, Red Hat, or Ubuntu, the Cloud SDK is cross-platform and freely available. So here are the components and capabilities. So let's break it down. G-Cloud, this is a Swiss Army knife of Google Cloud. It lets you create and configure VMs, deploy applications, manage IAM policies, connect to Kubernetes clusters, automate scripts and CI/CD tasks, and a lot more. If you ever run into something like the following, G-Cloud compute instances list, you've used it, okay? So there's no items. So BQ. BQ is your BigQuery companion. You use it to run SQL queries, load and export data, manage data sets and tables, and view usage and schema metadata. It's perfect for big data engineers and analysts who work with BigQuery from the shell. GSUtil. This is for cloud storage applications. Think of it as like the SCP and rsync for the cloud. It lets you upload and download files, set permissions, move objects between buckets, and apply lifecycle policies. So to get started, you're going to visit this website, cloud.google.com/SDK, and download this for your operating system. Then you'll extract the archive and run the following script. I'm going to put it in this dashboard, but you'll do this on your command line. You'll see this install that shell script. Once initialized on your local, remember, not here, not in the cloud editor, but in your local, you'll hit G-Cloud init. And this launches the setup wizard to authenticate your account, set your default project, and configure active configurations. So when you're working with the configurations, you'll be working on multiple projects like dev, staging, prod. And instead of switching manually, you can create naming configurations like create dev environment, right? You can set the project and region. Here are two examples of what those would look like. Set the project to dev project, set the compute region to US Central 1. All right. And then you can switch between configurations like this. G-Cloud configurations, activate prod environment, and you can list all configurations. All right. Oops. So it shows the configurations of where we already are, right? So this is invaluable in juggling multiple environments or automating across teams. So you can manage the SDK components. So here's a command to show that. Gcloud components list. So it shows a lot is already installed and ready to run, or not installed, not ready to run. Okay. And then you can add something new, like install qctl, that's Kubernetes, or you can do components update, right? Which updates everything. Oh, so I should have installed a little bit more specifically. That's okay. And then you can even access alpha or beta commands, which I believe might be deprecated because I think Google has let go some of their team. So here's a practical example. So let's say you want to spin up a VM for testing, right? This is one command you could enter. Spin this up. That might crash out, but it might not. So we might have a VM out to shut down. And then you could also use this to deploy Docker containers. So there it is, created that. All right. So this will spin up a Docker container. So these scripts can be saved and reused, automating your infrastructure as code. So the SDK for global DevOps is an integral part of CI/CD pipelines, infrastructure automation, IAM policy enforcement, and cloud-native development workflows. It works seamlessly with other tools like Terraform, Jenkins, Ansible, and GitHub Actions. So whether you're building a script to automate deployments, manage a multi-project environment, or just getting hands-on with GCP, the Cloud SDK is your command line cockpit. And as we continue exploring the toolset that powers modern cloud engineering on Google Cloud, we arrive at the foundational pillar of programmatic control. That's the cloud APIs. Whether you're writing a backend service that spins up VMs, querying BigQuery on a schedule, or building a dashboard that monitors traffic in real time, cloud APIs are how you speak directly to GCP at speed and scale. So what are cloud APIs? Cloud APIs are interfaces provided by Google Cloud that allow developers, applications, and systems to access and manage resources programmatically. These APIs follow modern standards like JSON over REST for easy human-readable API calls, gRPC, which is Google's remote procedure call for high-performance language-agnostic communication. This means whether you're working in Python, JavaScript, Go, Java, .NET, or Ruby, you have native libraries that let you interact with Google Cloud as if it was a part of your own code base. So there's cloud client libraries. There are two main types of libraries to choose from. Google Cloud Client libraries. These are the idiomatic libraries designed to feel natural in your language of choice. They support gRPC, offer automatic retries, and follow language-specific conventions. So your code looks clean and reads naturally. These are preferred when available, especially for long-term maintainability. And then there's Google API client libraries. These libraries provide access to REST APIs only and do not support gRPC. They're more generic and cover a broader set of services, especially the older or less frequently used ones. While not always elegant, they're useful when a cloud client library isn't available. So how do you enable APIs in Google Cloud? Before you can make use of any API, you need to explicitly enable it for your project, which you've done throughout these readings. This is a key security and billing consideration, preventing accidental usage or overexposure. So to enable an API, be in the console, we'll go back to this. All right. And so go to APIs. Let me see if it's here. API and services and library. All right. So here we can search for any API we want. All right. And so let's say, is there Terraform one? I doubt it, but let's see, IAC, infrastructure. Huh. So you would enable this here. And that's it. You're ready to use the service via the CLI, the SDK, or your custom application. So here's a tip. When you deploy a service like Cloud Run or App Engine for the first time, GCP will often enable the required APIs automatically. Still, it's best practice to audit and enable only what's needed. Securing API access. You can fine-tune API usage using IAM policies, service accounts, and OAuth scopes. For example, you might create a dedicated service account that can only call the Cloud Vision API and nothing else. You can restrict that account to read-only access on certain projects or services. This layered security approach ensures principle of least privilege, one of the core tenets of cloud security. All enabled APIs are visible on the API dashboard, which provides real-time and historical data like request volumes, latency and error rates, traffic by method or resource, quotas, and usage limits. You can access this by navigating to, let's see, APIs, and then APIs and services. Let's try this. Boom. So you see the dashboards, right? And you can monitor what's going on here. From here, you can drill down into individual services to understand what's being used, by whom, and how often, which is essential for auditing, troubleshooting, and capacity planning. So REST versus RPC, what's the difference? REST is representational state transfer. This uses HTTP with JSON. It's simple, browser-friendly, and widely adopted. And there's also gRPC, the remote procedure calls. This is a high-performance binary protocol that uses protocol buffers instead of JSON. gRPC is preferred when you need faster, more compact communication. You're dealing with microservices or high-volume traffic. You want bidirectional steering. REST is ideal for lightweight tasks, web apps, or when using curl, Postman, or basic HTTP clients. Example use cases. Let's say you're building an app that uploads documents to cloud storage and runs text detection on each file using Cloud Vision API. Here's how Cloud APIs would fit in. Your app calls the Cloud Storage JSON API to upload the file. Then it triggers the Cloud Vision gRPC API to analyze the text. Results are stored in Firestore via the Firestore API, and all these calls are authenticated via a service account. This is serverless automation, powered entirely by Cloud APIs. So, whether you're automating deployments, building client-facing applications, or scripting internal workflows, Cloud APIs are your bridge to Google Cloud, enabling you to interact, control, and scale your environments on your teams. And with cloud libraries, API dashboard, and granular permissions, you gain both developer velocity and enterprise-grade governance. So welcome to the final tool in our essential GCP toolbox for this chapter, one that brings the power of cloud engineering directly into your browser without any setup or installation. This is Cloud Shell, a fully featured interactive shell environment built into the Google Cloud Console, and it may be just one of the most convenient tools you'll ever use. And we have been using it. Okay, so what is Cloud Shell? Cloud Shell is a browser-based command line environment provisioned automatically for every Google Cloud user. The magic, it spins up a temporary compute engine VM, specifically a lightweight G1 small. This is an instance with 5 gigabits of persistent disk storage. This VM is pre-configured with the Google Cloud SDK, the Cloud CLI, and most common developer tools. This means no installation, no setup, no laptop compatibility worries. Whether you're on Windows, Mac, or Linux, or even using a tablet, your Cloud Shell workspace is just a click away. So how it works, when you click on this icon, a little terminal symbol in the top right corner, Google Cloud provisions a secure VM instance just for you. You're then dropped into a familiar Linux-style prompt. From here, you can run gcloud, right? gsutil, or bq. And standard Linux commands for editing, networking, and scripting. There's no initialization required, no separate configuration, just instant access to your cloud environment. Persistent versus ephemeral. Let's clarify something here. The VM created for Cloud Shell is ephemeral. It times out after 1 hour of activity, and the instance is destroyed when your session ends. But your home directory, $home, is persistent. So you get 5 gigabytes of private, durable storage that sticks around between sessions. Any files you save there, like scripts, templates, or project configs, will still be there the next time you return. Cloud Shell Editor. One of the most powerful features of Cloud Shell is its built-in code editor, a fully featured IDE experience based on Visual Studio Code embedded right in your browser. You can browse directories, edit YAML, or even write Python scripts. The syntax highlighting, autocomplete, and Git integrations are all included. This makes it easy to deploy infrastructure or update your app config without leaving the browser tab. For example, you're editing a main.tf file for Terraform or tweaking a deployment.yaml for Kubernetes. The editor makes the workflow seamless and intuitive. So you can see this here, editor. You can do all of this. All right. And there's a little boost mode. If you need a little power, Cloud Shell includes a boost mode. And this is an option that lets you temporarily upgrade your environment to the N1 standard 1 instance. This gives you more CPU and memory, which is perfect for running heavier scripts or builds without committing to a full-time VM. You just enable boost mode, and within moments, your shell has more capacity, still free of charge. Let's see. So you can see the Explorer, this Cloud Shell editor. This is very nice. Let's see if there's boost mode. You can upload, you can restart, upload, download, default, safe mode, ephemeral. This is nice, right? Session information, web preview. Now, where is boost mode? These are all edit features. All right, so let's close that out. I'm gonna authorize this. Open terminal. Open a new tab. Terminal settings. Those are just literal settings. Session information, web preview. More. I don't see a boost mode, but that might have been deprecated. A lot of things have. Web preview. Okay, we just saw this one right here. So this is a real-time app testing. One of the most underrated features of Cloud Shell is its web preview capability. So let's say you're running a local web server on port 8080. With Cloud Shell, you can preview this app in your browser securely without ever opening up a firewall rule or deploying to the app engine. Just click the red web preview button and choose your port. Let's say 8080 through 8084, and GCP will proxy your app over HTTPS so you can test it live. There's no public exposure, no DNS needed, just fast, safe previews. So here's a sample use case. Picture you're onboarding a new project. You don't want to install the SDK, configure service accounts, or set up your laptop. So you log into the Google Cloud, you log into the Cloud Console, open the Cloud Shell, and run the following. List the projects. All right. So you quickly identify the project, and then you enter the following deployment for your app. You monitor your logs, deploy your infrastructure, and edit configs all from the browser. Minutes later, you can review the web app using web preview. No install, no clutter, no time wasted. So key highlights for the exam. Cloud Shell uses a temporary VM with a persistent $home storage. It comes preloaded with gcloud, gsutil, BQ, and more. It supports Cloud Shell Editor for web-based code editing. It offers boost mode, potentially, for resource-intensive tasks. It's free to use with no setup required, and it's great for emergency fixes, lightweight dev, and teaching environments. Whether you're a DevOps engineer managing dozens of projects or a new learner practicing your first G-Cloud commands, Cloud Shell empowers you to get started instantly, anywhere in the world. It's convenience, it's control, and it's testament to Google Cloud's vision of developer-first infrastructure. Until then, keep coding, keep deploying, and keep learning. In conclusion, congratulations. You've now walked through the ecosystem of all the Google Cloud tools. Well, most of them. Each one is designed not just to perform a task, but to make you an architect of scalable, repeatable, and secure cloud environments. So let's recap. This deployment manager gave you an infrastructure as code natively in GCP, declarative, modular, and powerful. GCP Marketplace, a simplified provisioning, offering production-ready templates and applications with just a few clicks. Cloud SDK, which brought automation and precision to your fingertips, turning terminals into command centers. Cloud APIs, which taught you how to expose, consume, and manage services programmatically across languages. Cloud Shell, which gave you the agility, launching fully configured dev environments in the browser, no setup required. For the exams you encounter, focus on reviewing real-world usage scenarios. Know how to structure a YAML deployment file. Understand the difference between Google API client libraries and Google Cloud and Cloud client libraries. Be ready to troubleshoot API enablement errors and SDK misconfigurations. Practice common commands like gcloud, gsutil, and BQ and know their context of use. Learn how Cloud Shell integrates with IAM, project scoping, and browser-based development. More importantly, think like an architect. What problem does this tool solve? What is the trade-off? How does it scale? Mastering these tools means you're no longer just deploying our infrastructure, you're orchestrating the cloud. Next step, practice what you've learned, build small deployments, write scripts, explore marketplace templates, and simulate troubleshooting scenarios. Because in the exam and in the field, applied knowledge is everything. Thank you.